Hey, biology class. I hope you all did well on your test over the elements, compounds, and mixtures. Um, this class is supposed to be a study of living things and how living things work and some of the basics that we can get through in our short class period. Um, so I had you do some work on elements, compounds, and mixtures because when we study living things, it's important to understand what they're made of. And in this video here, I have a colored version of the periodic table of the elements. And if you need to use this for some of the work, you can always pull the video up and you'll have one there with you. Each one of these squares represents one element. And the overview of this table of the elements, they've put them in this table, they've arranged them according to increasing atomic number. And when they set it up like this, some patterns fell into place. So that's why they're color coded. Basically, your metals are on this side of the table. These are technically called alkali metals, alkali earth metals. Then you have transition metals through here. And these right here, there's like a stair step here. These are called the metalloids. And it depends upon what kind of conditions or what they're combining with. Sometimes they will act like metals, and sometimes they act like nonmetals. Then your green here are your nonmetals, and these are here are called the noble gases. They really don't like to bond with anything, and when I get through with the video today, I think you'll understand why. Each one of these squares represents a different element. And remember that there are 92 naturally occurring elements on Earth. And we have these two rows down here, lanthanide series, actinide series. And if you look right here on the table, they're color coded. This whole row actually inserts in here, and the green row would insert in here. The reason they drop them down below is that it makes the table fit on one page, and these atoms here have some similar properties, not properties, but it's the way they fill up certain energy levels with electrons, is why they can separate them out and put them down below. And by the time I get done, you'll have a little bit better understanding of that. So we're going to eventually get to the point of, I want you to be able to look at one of these boxes, and from the numbers, you're going to be able to figure out some information about individual atoms. And then hopefully you'll understand why these atoms may pair up with another atom and form a molecule or a compound. And that's really important to understand why these atoms combine, because we are basically chemical combinations that have the properties of life. And once you understand kind of some basics of what makes you up, then you can understand why certain reactions occur in your body. It just kind of makes a little bit more sense. So we're going to start here with the basics with an atom. And at this point, I would probably have some paper, and that way you can kind of follow along and take some notes. I look for worksheets, I look for tables, and I'm just kind of like, I've spent a lot of the time today trying to figure out the best way to present this. And I just didn't want to throw out a 3-minute video and hope you got it. So you can pause the video and get you some paper and something to write with. And we're going to get started here. Why don't you try doing that? Grab something real quick while I kind of reposition the camera so you can see what I'm going to be drawing. Okay. So I'll make this a little bit bigger image. Don't want to go full screen. Here we go. I need to figure out if I'm going to be writing right side up or upside down. Let's put a little A over here and see what happens. All right, let me do some switching around here where you can see it better. Okay, that looks a little bit better. So atoms. Okay, so we're going to start. I'm going to switch back. I'm going to be moving back and forth here, so you guys have to bear with me. Let me cut back to here, and we're going to talk about hydrogen. Okay, so this is going to be one box on the periodic table. You don't have to draw yours quite as big as what I'm drawing mine so everyone can see. So in each box, there is a 1 or 2 letter symbol. Some periodic tables, they have a different nomenclature way of naming things, and they might have a symbol with 3 letters in it. The first letter, or if it's the only letter, it's always capitalized. And if there's a second letter, it is a lowercase letter. Sometimes the symbols make sense because the letter starts first, the symbol is the first letter of the name of the element, but some of our elements' names are taken from their Latin names, like copper is actually cuprous. That's why it's a Cu. And iron, Latin name I believe is ferrum or ferrous. So that's why they have some different symbols here and letters here. Some of it's taken from the Latin. There's generally 2 numbers in each box. There is a whole number, one without a decimal, and that is called the atomic number. Whole number without a decimal called an atomic number. And then there's generally another number with a decimal, maybe referred to as atomic weight or mass number. Okay. So let me make this a little smaller. And here you can see on this periodic table, they're referring to it as the atomic weight. Okay. Now, basically, what those numbers tell you, they're little clues that can help you figure out trends in the periodic table. I am not one that makes people memorize the periodic table because if you're going to be working in science or if you're going to be a chemist, you're going to have a periodic table in front of you. And the more you go through your education, if you go into a science field, the more you work with these elements, you're going to end up memorizing them anyway, and memorizing the numbers that you need. So it's more important to me that you understand the trends in the table and some properties of the table, and that will give you a better understanding of chemistry, in my opinion, rather than just memorizing symbols and names. Okay. The ultimate goal of this is to help you understand how these atoms combine to form molecules. And that will help you hopefully have a better understanding of living things and some of the chemical reactions that go on inside these cells and tissues in order to sustain life. So that's where I'm going with it. We're starting with the basics so you can have a better understanding of how a lot of the things that go on in a plant or an animal, it's all based on chemical reactions. And once you have some real basics of what holds those atoms together, kind of makes some of the other stuff will make a little bit more sense, hopefully. So there are basically 3 common particles that we talk about with an atom. An atom, basically, you've probably heard of protons. Protons, P, positive charged particles. And these particles are very tiny. Protons and neutrons are about the same size. Neutron in neutral, which means it does not have a positive or negative charge associated with it. I usually use 0 with a slash. Then the other particle is significantly smaller than the protons and neutrons. These are about the same size. They're actually assigned a weight of about 1 AMU, 1 atomic mass unit. And then electrons are significantly smaller, and they carry a negative charge. And basically, the protons and neutrons are located in the nucleus of an atom, and the electrons are orbiting that nucleus. Now, on some worksheets, they're going to draw the nucleus as a circle. And that's okay, but when we start talking about electrons and where they're going, talking about energy levels or orbitals, we use circles to represent those sometimes. So then it becomes a question of, is that inner circle the nucleus, or is it the first energy level where you find electrons? So I like to draw a square for the nucleus of the atom, and the nucleus is going to contain the protons and the neutrons. The lines there are there because we're going to write numbers on them. It helps you figure out the property or the structure of the atom. So this atomic number, let me give you a chance to look at that. I had that kind of small. So protons, positive 1 AMU. I'm going to see this will focus in and out a little bit better, maybe. Get a little sharper. Neutrons, no charge. Electrons, a negative charge. Protons and neutrons go inside the nucleus, and then the electrons are orbiting around. And what I want you to realize is atoms are not flat pieces of paper like this. They're not flat. They're three-dimensional. They have, they're kind of like the nucleus is kind of clustered together of particles, and they kind of form a sphere. And the electrons are orbiting around them, okay? And it's kind of like if you've ever been to an airport and you see that they're having trouble getting the planes to land, they'll stack them up in the atmosphere. And that's kind of what electrons do. They're kind of hovering around the nucleus. They're kind of like little moons going around the nucleus of an atom. So these numbers here will help you figure out how many protons and neutrons are in each atom and how many electrons are there. So basically the atomic number tells you the number of protons, or it can tell you the number of electrons. And the reason I'm using the word or is if I say it tells you the number of protons and electrons, sometimes people get confused and think the number is a combination of both of them. Actually, that number can tell you the protons, and it's also the number of electrons. Then the mass number here is made up, or the atomic weight is made up of protons and neutrons combined. We basically consider it the protons and neutrons because the electrons are so tiny. So if you know that the atomic number is 1, and that this element or this atom has 1 proton, and the mass number is 1, or the atomic weight's 1, and that's a combination of them, by subtracting, you can figure out how many neutrons are there, okay? So if the atomic weight, and we round the atomic weight to the nearest whole number, 4 and smaller, it reverts to this number. If this number is 5 or higher, you go up to the next whole number, which would be 2. So it's a 0. So the atomic weight is 1, and that is made up of the protons and neutrons combined. And then if we subtract the atomic number, which is also 1, That leaves us, which is the protons, atomic numbers, protons. We subtract the atomic number from the atomic weight, it will give us the number of neutrons, but 1 minus 1 is 0. So hydrogen is an atom that has 1 proton, 0 neutrons. Okay, so hydrogen has 1 proton, it has 0 neutrons. Now, I also told you that the atomic number can be the number of protons or it can be the number of electrons. So hydrogen will have 1 electron and it will go in its first orbit or energy level. Now, the bigger the atom becomes, the larger the atoms are that we're going to discuss, the more energy levels they have, but they do follow a pattern. So that is how you diagram a typical atom of hydrogen. Now, I'm going to talk a little bit more about these energy levels at this point. I'm going to just say if we had a larger atom from an element that has a higher, that has a larger atomic number. Let me zoom out here for a minute. Okay. All right. I made that a little large. Okay. So now hydrogen is not a metal. It's over here. It kind of balances out the periodic table, and it is the element before the next noble gas, which is helium. So, and notice that the atoms in the periodic table increase sequentially going across the table. So let's talk about lithium next. Okay. Lithium has the atomic number of 3, and its atomic weight is 6.94. Atomic weight is 6.94, which means that lithium has 3 protons, or it has 3 electrons, because that's the atomic number. Tells us protons and electrons. And then here is the atomic weight, which we will round to the next whole number. This is above 5, so this makes this go to 7. And the atomic weight can be the protons and the neutrons combined. So if I was going to diagram an atom of lithium, I'm going to draw my nucleus. Kind of, it's too small. And the number up here tells me my protons. So it has 3 protons. And then to find the neutrons, I'm going to subtract. Remember, I'm going to take the atomic weight, and I'm going to subtract from it the atomic number, and that's going to give me my number of neutrons. So my atomic weight here, rounded, is 7. My atomic number is 3. So 7, which is the combination of protons and neutrons, and you take away the protons, that leaves you with the neutrons. So 7 minus 3 means that lithium is going to have 4 neutrons in the nucleus. Now, once again, however many protons the atom has, that's how many electrons it's going to have. This first energy level, because it's close to the nucleus, and electrons have a negative charge, and like charges repel, you're only going to get about 2 electrons close to the nucleus, because when they come in contact with each other, they're going to repel and push away. So that means that the third electron has to go out here in the second energy level, and that one can hold up to 8. So we can add energy levels as the atomic number increases to accommodate more electrons. So for practical purposes, what you need to know, we won't get past the third energy level in here talking about this stuff. So, and I'm just going to draw a half shell so I've got some room to write. This is the first energy level closest to the nucleus, and it has it will hold a maximum number of 2 electrons. First energy level will hold a maximum number of 2 electrons because they are oppositely charged, or they're like charges, they'll repel each other. Okay, the next level out, you figured it out, is the second energy level, and it maxes out with 8 electrons. I'll give you some time to write that down. Great thing about videos is you can go back and rewind and watch it over again if you don't catch all of it. And the next energy level out is called the number 3, third energy level. And it maxes out with 18 electrons. So 2, 8, 18, and actually a fourth energy level starts filling before the third energy level completely fills, but we're not going to be dealing with atoms that large at this point and trying to explain ionic and covalent bonding. So to summarize, everything's made of matter. Matter can be made of elements, compounds, or mixtures. And this table here represents the elements that we know of. Elements 1 through 92 are natural occurring elements in our Earth. But the elements represent atomic particles, atomic referring to atoms. And by knowing some of the numbers in these boxes and what they represent, we can kind of draw a model of an atom. Remember, these things are very small. You need like electron microscopes to figure out their location, even in crystals. And so this model is a good way that is kind of, the people in the scientific world have kind of decided this is the best way to describe these tiny particles of matter that we can't see, but that we're made of. Okay. And so the basic particles of an atom, and they've discovered other ones since, a lot of the older science books were written. They know that there's quarks. They believe there's anti-protons, anti-neutrons, anti-electrons, or positrons. So, maybe not positron. That probably wasn't the right word to use. I'll have to look that one up. Anyway, so basically, you need to know the 3 basic particles of an atom: protons, neutrons, and electrons. And what we're going to be mainly focused with are the electrons, because atoms will actually share electrons, or they will give them away, and some other atoms may accept them. And this all goes on pretty much with the atoms in the outer energy level, because the atoms are trying to become stable. And the atoms are most stable when their outer energy level is filled or it has 8 electrons. Now, that doesn't hold true for the first energy level, because the first energy level can only hold 2 electrons. So if you have an atom with only the first energy level, it will be stable with 2. The next energy level will hold 8, and that atom becomes more stable as that second energy level fills up and has 8 electrons. The third energy level, those types of atoms would like to have 18 electrons in their outer energy level, 8 being in that particular energy level there. Okay, so as these atoms fill up going across the periodic table, they're becoming more like, or they're trying to achieve the electron configuration of noble gases. Helium has 2 electrons at its highest energy level. That first energy level is filled. Helium is stable and it does not want to combine with any other elements. Neon has 2 in the first energy level, 8 in the second. Its second energy level is filled. It doesn't want to combine with anything. Argon has 18 and it has 8 electrons in its highest energy level. And let me say this, it can be filled or have 8. 8's the magic number. It's called an octet. So argon can have quite a few electrons, but it is stable with 8 electrons in the highest energy level. And you can go down the noble gases. So atoms will bond with atoms of other elements to try to get 8 electrons in their highest energy level or have their highest energy level filled. Okay. All right. So at this point, I'm going to stop and kind of let you digest some of this information. And then I will probably put out another video tomorrow and be looking for a worksheet over the particles of an atom as a review. But I think this is enough for one night. I really need you to study this and kind of go over this, watch the video a few times so you have this down before we start the ionic and covalent bonding. And that will be the next video. And I may even push that one out between Wednesday and Thursday. We're going to keep building on this and talking about how these atoms are now going to share or transfer electrons to have 8 in their highest energy level and become stable. Okay, guys, so there's really not an assignment for this part right here. You just need to focus on this because there will be another worksheet coming, and I want you to have some time to kind of digest this information. All right, talk to you soon.